Hi everyone. In today's lecture, we will discuss artificial intelligence and advanced application. I am Dr. Ravichandra Janapati, Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal. What is artificial intelligence? So artificial intelligence means which mimics the human brain. So the term itself indicates that the intelligence which is artificially made. So what do you mean by that? Here, normally we have natural intelligence. The opposite to the artificial intelligence is natural intelligence. What is meant by natural intelligence? How human being develop natural intelligence. So usually when we born, we don't know anything. So what will happen? Our mind will be trained with different things like this is cat, this is dog, this is mom, this is dad, or this is pen, this is pencil, this is book, this is apple, this is like that, different things that can be trained in our mind. So usually our elders will use to explain or use to train our mind with different things. So that thing that will be stored in our mind will be trained, and we are able to identify the things in next whenever we met with that type of things. So at initial stage, we don't have anything. We don't know anything. Our mind is empty. Our brain is with empty. So in a similar manner, machines also trained in such a way that machine is nothing but models will be trained in such a way that it should be trained with the different things. So that is called artificial intelligence. Like, so the more we will in the artificial intelligence, we will develop some models. That models will be trained, and that machines or models will be trained, and which can be simulate human intelligence, which can provide learning, reasoning, and problem solving and decision making skills. So this is regarding AI. Artificial intelligence means the machines will undergo training, and which can give problem solving and decision making things. Coming to artificial intelligence, it enables machines to mimic human intelligence. Usually, these machines will mimic the human brain. AI can learn, analyze, and make decisions from the data. Examples: speech recognition, face recognition, self-driving cars. In speech recognition, like Google Assistants, here it will identify the speakers. In the face recognition also, usually in any mobile or any authentication system, we use face recognition system. In self-driving car also, we can use this particular AI things. Now, AI is powered by signal processing and machine learning. AI usually powered by signal processing and machine learning tools. Coming to the examples of artificial intelligence, nowadays we are using Siri, Alexa, which are AI assisted tools to understand speech, answer questions, and perform tasks automatically. So here, this is regarding Alexa and Siri. So these are the examples of AI. So where we can easily identify or we can easily answer the questions. These AI models easily answer the questions. Now, coming to speech recognition applications like Alexa, as well as Siri and Google Assistant. So there are different things will be there where this can be easily identify these tools, these tools developed by different companies. They can easily identify as well as they can solve the real-time problems. Now, another advanced application of AI is smartphone face unlock system. So in this smartphone's face unlock system, which involves not only AI, it involves different applications like psychology, neuroscience, AI, and philosophy. So there are different fields will be involved in this. So coming to this psychology, which can be used in face perception, neuroscience, which can provide brain face processing, AI, which can provide face recognition algorithms, philosophy, which can identify verification. So in this face unlock system, it recognizes your face using AI as well as brain-inspired processing and human perception concepts. Now, the applications will be mobile security, banking authentication, smart attendance system. Now, another applications of AI is EEG-based emotion detection system. EEG-based emotion detection system. This is the another application. So in this, what will happen here? The person, when he see happy moments, sad moments, neutral, fear, there are different things. His mood will be in different moods. Then we will acquire the data from EEG as well as eye tracker. This data will be given to, from this data, we can take features from eye tracker as well as from EEG. Then we can give it to some deep learning model. then which can classify whether the person is happy, sad, neutral, or fear. So these things can be easily classified whether that particular person is happy, sad, neutral, or fear. Now, in EEG-based emotion detection system, we can measure brain activity and AI. Using EEG, we can measure the brain activity, and AI predicts emotional states like stress or happiness. Coming to the real life applications, mental health monitoring, gaming, healthcare applications, brain-computer interfaces. Now, smart voice assistants. Here, these voice assistants understands human speech and process language and respond intelligently. The real life applications will be smart homes, customer service, mobile assistants. Another application, self-driving cars. Self-driving cars. In self-driving car, there are different components will be acquired with the car. In that, one is GPS device, LiDAR, camera, computer, wheel encoder, as well as radar. So these things can be integrated with the car in self-driving car. Now this radar can find, detect range, and it can track. This GPS also use it to find the location, tracking. Then camera, which can observe the things. This processor will process the information. Then we have wheel encoder. So in this, in self-driving car, without driver, we can reach the target, or we can reach the destination. So in that, there are different fields can be involved, like AI, which can be used for object detection, psychology, which can be used for decision making, neuroscience, which can give visual perception, then engineering, which can be used for automation of systems. Now coming to brain-inspired prosthetic. So this is an interdisciplinary area where some people are suffering with neurological disorders like disability. They are unable to move their hand. They are unable to walk from one place to another place, or they are having some Parkinson diseases. So in such cases, when they need to have some prosthetic hand, which can be which can controlled by brain signals. So for that, we have to acquire. We have to acquire this. We have to acquire the data using EEG cap. Then with that EEG, we can easily identify intention signals, then which can be given to human brain or robotic arm, which can be used to pick an object or source of location. So this is simple prosthetic hand which can be controlled by brain signals. So in this prosthetic hand, brain signals are used to control robotic hands for disabled patients. Coming to real-time applications, one is rehabilitation, second one assistive technology, third one healthcare robotics. So these are the applications of EEG based prosthetic hand. Now, coming to the timeline of AI. Usually AI is evolved long back, but why it is not popular that much? Because even though concepts are there, but we are unable to process that information. We don't have that much speed machines in that time. So because of that, it is not become popular. We have AI long back. Now, we are going to discuss the timeline of AI or evaluation of AI. In 1950, Alan Turing, he want to test whether machines having intelligence or not. Whether machines having intelligence or not. So that test is called as Turing test. The test is called as Turing test, which is evolved in 1950. In 1956, the first time they used one term that is artificial intelligence, AI. AI stands for artificial intelligence. In the conference, Dartmouth Conference. In the Dartmouth Conference, they used one term, artificial intelligence. In 1956. In 1980, IBM and Microsoft, they started using expert systems like autonomous systems without human interventions. They can work. These systems will become popular in industries. That is in 1980. In 1997, IBM developed one AI or robot that is Deep Blue. They say this defeated one famous chess champion, Gary Kasparov, in 1997. This happened in 1997. In 2010, the deep learning and generative AI become rising and they become more popular compared to the previous years. So this is the history or evaluation of AI, artificial intelligence. Even though the AI evolved long back, but why it is not widely used? Because we don't have high-speed processors. Nowadays, we have GPUs and other high-end processors are there. So because of that, we can easily run the AI models. But previously, we don't have that much high-speed processors. Now, interesting question. What AI can do actually? What AI can do? AI can perform 4 different types of tasks. Basically, it can perform 4 different. Broadly, we can classify into 4 different types of tasks. One, predicting. Two, suggesting. Three, classifying. 4, generating. What do you mean by predicting? Predicting means weather predicting or temperature or rain forecast. So these are comes under predicting. Nowadays in our mobile phone also the temperature, humidity that can be predicted. So that is called prediction, estimation. Now another task which can be performed by AI is suggesting. Now, for example, in the Google, in the YouTube, we are watching some entertainment videos or some kind of news like national politics or international politics. Then for that people, it suggests next video also like that. Or if we watch spiritual videos regularly, that YouTube suggests spiritual videos. If you listen music, next also it suggests music. So that is suggestions. In the similar way, Amazon, Flipkart, these are e-commerce companies. These also, based on your search history, these also will suggest you the products which are related to your interest. This is regarding suggestion. Next, classifying, classification. Now, classification means we want to test or we want to classify this person having disease or not. So based on the reports, it will classify. So if you go to doctor, he will test. So based on the whether this person is having that type of disease or not. So whether yes or no. So that is called as classification. So we can classify frequencies, we can classify whether harmful, this data is harmful or not, this content is whether it is bad or good. Like that, we can classify, or we can classify this is cat or dog. Based on its features, we can classify. Next, another one is generating. Generating means we can generate text, we can generate images, we can generate videos using AI. Already we are using ChatGPT, Gemini, DeepSeek. These are all generative AI tools. So these regarding what AI can do. Now, what is machine learning? Machine learning is a subset of AI. It is a subset of AI that enables system to learn from data and improve performance without explicit programming. It is similar to AI, but here it is a subset of AI. So, which enables system to learn from the data and improve performance. So that is called machine learning. Now, this is the relation between AI and machine learning and deep learning. Artificial intelligence or simply is the main one, bigger one. Then in that, the subset is machine learning. In that subset is deep learning. Deep learning. Artificial intelligence, which mimics the human brain. Machine learning, the models or machines can be trained. Deep learning, we use ANN and deep neural networks to train our model. Now, what are the machine learning techniques? What are the machine learning techniques? There are different machine learning techniques will be there. One is supervised learning, unsupervised learning, reinforcement learning, deep learning. There are different types of learnings. One is supervised learning, unsupervised learning, reinforcement learning, deep learning. What do you mean by supervised learning? Supervised learning means with labels, we can identify or we can classify the data. So in the supervised learning, we are going to use labeled data. Unsupervised learning. So in unsupervised learning, the data is raw data. We're not taking the labeled data. That is called unsupervised learning. Next one is reinforcement learning. By using the task performance, we can give rewards. So based on that rewards, your model will be trained. That is called reinforcement learning. Next, another one is deep learning. Deep learning means here we are going to use some ANN models, artificial neural networks models, as well as convolution neural networks models. So which can be trained and which can be biologically inspired. Algorithms can be developed. So we can train our models. That is called deep learning. Now, coming to supervised learning. So in the supervised learning, here we have labeled data. What is this labeled data? This is the input. What is this input? We are going to train this as apple. We are going to train the model. This is the labeled data, input data, that is apples. These are apples. We are going to label these are apples. We are going to label these are the apples. With this data, we are going to give labels also. So hence, it can predict. Whenever you find apple, it is easily recognized this is apple. But in unsupervised learning, we will give only raw data with mixture of apple and banana. We can give this one. And we can train our model. The features of this one, features of banana will be trained. and we can easily classify this data. These are the apples, these are the bananas. Like that, we can easily classify. So in unsupervised learning, we don't have labels for the data. In supervised learning, we have data will be labeled. So that is the difference between supervised learning and unsupervised learning. Now, coming to unsupervised learning. So in this, we are giving, just now we discussed. So input raw data, like we have onions, brinjal, and capsicum. So these are the different things, unlabeled data. We are not going to label initially. So first we are going to interpret, then we'll give algorithms, then we are going to process, and this one will give it to the output. So that is called unsupervised learning. Next, another one is reinforcement learning. So now in reinforcement learning, machine learning paradigm that focuses on approach which can be given rewards. If it is a correct approach, you will give positive reward. If it is a wrong approach, you will give negative rewards based on your action will be rewarded and the data will be learned. Next, another one is machine learning. Sorry, deep learning. In the deep learning, we have model. There is no separate feature. Actually, in machine learning, we have feature extractions. But in deep learning, the itself take the feature extraction and which can classify the data. So which can easily identify, classify whether car or not car, whether the input is car or not car. So if we are using machine learning, so we need to take the features of the car track individually. But in the deep learning, this model itself having feature extraction, then which can classify, which can give the output. So this is regarding deep learning. Now, what is AI agent? AI agent is a system that perceives its environment and takes actions to achieve specific goals. The difference between AI and AI agent is AI is generally do the things, but agentic AI or AI agent will do the specific task and it have some specific goals. For that, it perceives the informations from its environment and takes action to achieve the goals. AI agent collects information, process it, make decisions, and perform actions automatically. Coming to types of AI agents. Types of agents. Simple reflex agents, model-based agents, goal-based agents, utility-based agents, learning agents. These are the different types of agents. Now, what is agentic AI? Agentic AI is a type of AI system that autonomously make decisions, plan actions, and execute tasks to achieve specific goals with minimal human intervention. So that is called agentic AI. So what is generative AI? So generative AI is a AI which can generate content such as text, images, audio, video, code, and designs by learning patterns from the existing data. So this particular model will be trained like ChatGPT, Gemini, or any DeepSeek or Claude. So these things can be trained. We're going to train our models. Then this can give. So the example of agentic AI. So here, the particular user, he will ask, plan 1 week trip to Jaipur. So the AI agent, what it will do? It will calling tools. It will search for flight, then it flight options, then and its prices, then and it also find top attractions in the Jaipur and will book some flight ticket. So that is the job of agentic AI. Now, how agentic AI works? So first, perception will perceive the data, then reasoning finds the reasoning, then it sets the goal, decision making, then execute, learning and adoption, then it find the output. So that is regarding how agentic AI works. So this is regarding AI and its advanced application. In today's lecture, we discuss what is AI, what are the advanced applications of AI, and what is agent AI, what are the agentic AI, and how this agentic AI works. Thank you, one and all.